Now, so far, when we did a kernel launch, we basically told CUDA to execute A blocks of B threads each. So the assumption was that both the number of blocks in a grid and the number of threads in a block are just a single number. But since CUDA is designed to help process multidimensional data, such as images, for example, both the number of the thread blocks and the number of the threads in a block are actually three-dimensional structures. So essentially, you can define a grid of A by B by C blocks with each thread block containing X by Y by Z threads. Of course, you don't have to make it 3D. You can have the shape of a 1 or 2 dimensional structure just by setting the extra dimensions to 1. Now, to define these 3D arrangements of thread blocks and threads, you use a structure called dim3, which is just a simple structure with 3 integer fields x, y, and z. And it does define a few constructors in case you're using C++. And as you have already seen, there is an automatic conversion from a kind of comma-separated specification. So writing A, comma B effectively gives us an A by 1 by 1 grid of B by 1 by 1 threads. A running thread has all the information about the parameters that were used to execute the kernel, as well as its own position on the grid and thread block. So we have block IDX, which tells us where we are currently in the grid. We have grid dim, which tells us the size of the grid. So its X, Y, and Z values effectively correspond not to the position, but rather to the size of the dimensions. Then there is thread IDX, which we have already seen, which tells us the position of the thread in a thread block. And finally, there is block dim, which tells us the size of the thread block that we're in. Now, you're probably wondering, if it's up to me to define the dimensions of the grid and thread blocks, can I make them as big as I want? Well, the answer is no. You do actually have some limitations in the size of these structures. So if you open up the system info window, you would see the following. First, you would see the limitations on the grid and block sizes. So max block dim and max grid dim will tell you the limits on the size of the grid and the size of the thread blocks that you can make. You can see from the screenshot here that on the device where I was taking the screenshot, the max grid dim Z is actually set to 1, and this means that the grid on my machine is actually 2-dimensional, so the third dimension is not supported. And indeed, the third dimension of grids was only supported starting from compute capability 2.0, and since I have a 1.2 device, I don't yet have this capability, and that's why I have max grid dim Z set to 1. And another limitation is the overall number of threads that you can have per block or per SM, and this is again something that you can find on the system info page.